So the only thing remaining in this unit is actually to do a couple examples of doing circuit analysis here, circuit analysis. With steady state. And we've actually already done that. We've done two examples. They are relatively simple examples. What I want to do is do some more where we're going to have nodal and mesh analysis, and where we're going to encounter something that at first looks like it's going to be challenging to solve, but I'm going to provide a link to a website that enables it to be pretty easy to solve, or you might have a calculator that can do this, but not all calculators will be able to do this. So I'll provide a link to a website that can help you solve these problems. So what we're going to first start with here is I'll give you the circuit. Now, this is an example here, and this happens a lot where the circuit is being given completely in phasor format. Okay, so this is the circuit we're given, and the instructions are to use mesh analysis, loop analysis, to find I1 and I2. Now, this is not going to be as bad as you might think it is, because you might think, oh, I've got these complex numbers. Most of the work is going to be involved in setting up the equations. And if we set up the equations correctly, then we're going to use a calculator online that's going to do all the other extra work for us and spit out the answer. I don't want to download that. All right, so what we're going to do here, well, I'm going to draw my loops here. And clearly this loop is just I1 because of its being the current here, and this loop is just I2. And so I'll start with loop 1. And I'll kind of note the different things we're hitting here as we go through here. Well, actually, before we do this, maybe let's convert everything into the same units, because we have rectangular and polar. And it's going to be helpful that everything is in the same. So let's convert all of these voltages to rectangular format. So 10 at an angle of 0 degrees would be 10 cosine of 0 degrees plus 10 sine of 0 degrees, which is equal to 10 volts. So this is 10 volts in rectangular. Then 15 at an angle of 90 degrees would be 10 cosine of 90 degrees. I'm sorry, there should be a j there. Plus j 10. Let's actually not rush through these here. I'm rushing. 15 at an angle of 90 degrees would be 15 cosine 90 degrees plus j 15 sine of 90 degrees, which would be j 15 volts. So this is j 15. And then 20 at an angle of 0 degrees. Yeah, we could write out the whole 20 cosine 0 degrees plus j 20 sine of 0 degrees, and that's still just 20 volts. Okay, so loop 1 here, I'll start with this power supply here. So I'm hitting in on the negative side, so I'd have minus 10 plus, well, the voltage across this inductor would be J5 ohms, because that's the resistance, or the impedance, times I1. And then I'd have plus 3, but then I have I1 minus I2, because I have I1 coming down and I2 is going up. So they're going against each other. So I1 minus I2. And then I'm hitting the plus side of that power supply, so this would be plus J15. And this is all equal to 0. Then if we simplify this equation here, we can see that, well, I will move this 10 and this J15 to the other side, so I'd have 3 plus J5 I1. So what I did there is I just combined this J5 and this 3I1 minus 3I2. So what I did there is the 3 and the minus I2 is equal to, and then I move the negative 10 to the other side, so that'd be positive 10. Move the positive J15, so that would be minus J15. And so here is one of my equations, equation 1. Now I'm just going to do loop 2 in a very similar manner. Loop 2, I'll go ahead and start at the J15 source. So I have coming in on the negative side of that, so I have minus J15 plus 3, and I'm in loop 2, so it's I2 minus I1. They're still subtracted because they're fighting each other, but it's I2 first because I'm in the I2 loop. Then I have this capacitor, so that would be minus J4 I2. And then I hit the positive side of that, so it'd be plus 20 equals 0. And so then what do I have here? Well, combining like terms again, I'd have minus 3 I1 plus, and then, because that again is coming from those terms right there, and I like to make sure I wrote I1 first here, so I'd write I1 first here. And then I have 3 I2. So I have 3 minus J4 I2, and that's coming from this 3I2 here, this minus J4. Then I'll move this and this to the other side. Excuse me. So I'd have minus 20 plus J15. So this would be my second equation. Now this is where it looks like things would be kind of nasty, because what do I end up having really? What I have here is I have 3 plus J5 I1 minus 3I2 is equal to 10 minus J5, 15. And then I have minus 3 I1 plus 3 minus J4 I2 equals negative 20 plus J15. And I have a system of equations and a system of equations and unknowns. And so I'd have to solve this. But the difficulty becomes I've got complex numbers, so it actually becomes a little bit more challenging to solve. But if we write it in a matrix form here, and all I'm doing is putting the numbers in here, If I do that, well, I can do a matrix operation. Once I've put the matrix here, this is a 2-row, 3-column matrix, and all I've done is put the numbers in here directly from the equation. And if I do something called reduced row echelon form, what I'll wind up with is the following. I'll have something that looks like this. I'll have a 1, 0, a 0, 1 here, and then I have two numbers here, and I'll say answer 1 and answer 2. Because what these will be here is that I1 will be answer 1, and I2 will be answer 2. All right, so now we need to actually do that, and that's where I said this link that you can find online on Blackboard will show you how to do it. It will link you to this page here. And it's a calculator you've seen me use before, but it has the ability to do matrices. So the first thing you're going to do is you want to type in whoops, I did reload there, RREF, parenthesis, and then I want to do, well, it's a 2 by 3 matrix, and then I just enter all those things in. So the first term was 3 plus J5, so 3 plus 5I. And then the next term was negative 3. The next term was 10 minus J15. The next one was negative 3. Then we have 3 minus 4I. And then we have minus 20. Whoops. Minus 20 plus 15I. Now I've entered it all in, and it's doing some computations. And of course it gives me in fractions. Great. That's not very helpful. But I'll write the fractions down here, and then we'll get the decimal numbers. But it went ahead and did all of the computations for me. So the answers here would be negative 1920 divided by 409 minus I 530 over 49. So minus J 530 over 409. This is I1. Amps is equal to I1. And then 2400 over 409 minus J 1685 over 409 amps is I2. And so let's go ahead and compute what those things are here. So, well, actually, I'm going to pause the video and go through these computations and then write them down. Okay, so magically 2 more lines should have appeared on your video, and all I did was use my calculator to divide these out. So you get minus 4.91 minus J 1.3 amps, 4.57 minus J 4.12 amps. Now typically we want to write these in magnitude and angle form, and that's because we want to be able to write I is equal to something cosine, you know, et cetera, et cetera. So we need to convert these to polar format. Now, again, we have calculators that can do these for us, and I'm going to use my calculator to do this for me, and I'm going to pause it for a second. And so again, magic of time lapse here, I converted these to polar format, and I got 5.08 and an angle of negative 165 degrees amp, 6.15 and an angle of negative 138 degrees amp. And now it's not necessary to do this step, but I always like to do it kind of thing. What that means is we have 5.08 cosine omega t, because I have no idea what the frequency is, minus 165 degrees amp for I1, and I2 is equal to 6.15 cosine omega t minus 138 degrees amp. Okay, so let's take a look at this problem again before we move on or end this video. So first off, we should emphasize that we're just using Kirchhoff's voltage law mesh analysis like we did in the previous course. And what we should see here is that there's nothing really different except we're having complex numbers. Now the one thing I want to caution all of us on, including me, because you know I can make these mistakes as well, is that it's very easy to make a sign error, having a negative in the wrong place, something of that nature. So when you're doing these for your homework problems, make sure to write out as many details as possible, because honestly, if you want to talk about earning a majority of the points for a question, if you can get these two equations done correctly here, even if your answer is somehow wrong then because you did something wrong in entering it in, if these two equations are correct, you're going to get at least 90%, if not more, of the points on the problem. Because this really is the key factor. Do you understand that the voltages in a loop add up and sum to 0? And that you can, when you do that, then you can do the impedance times the current, things of that nature. So these are really the two critical pieces. If you don't understand how to get to these, make sure to rewatch the video. Also do it yourself. And you also might want to look on the YouTube channel that these videos come from, because you can go back and look at videos from EET1200 that deal with Kirchhoff's voltage law and current law, and see some more examples. Now they'll only use resistors, but it will give you some good practice or refresher if you don't remember this.